So good afternoon students. I am Dr. Senthil Kumar from IT department working as assistant professor Sri Muthukum Institute of Technology. I am handling the subject of subject code CCS 335 Cloud Computing Regulation 2021 syllabus. So next we are see the continuation of Unit 2 Unit number 1. NIST Architecture Reference Architecture. NIST Architecture is a standardized framework for defining cloud roles, service models, and functional components. It is identified 5 key factors: consumer, provider, auditor, broker, and carrier, and outlines a conceptual reference model called IaaS, PaaS, SaaS, and FAS, designed to accelerate, secure, most cost-effective cloud adaptation. 5 major factors are cloud consumer, cloud provider, cloud auditor, cloud broker, and cloud carrier. This is the reference architecture model for this cloud NIST reference architecture. First one is we see the cloud consumer. The cloud consumer we have cloud auditor, securing and auditing, privacy impact audit, performance audit. This is the cloud consumer for the control of using auditing parameters. Next one is cloud provider. Service layer, SaaS, PaaS, and IaaS. Service auditable and control layer, physical resource layer, and application layer and protocol layer. Next one is cloud service management, cloud environment support, post relay subject, post deploy infrastructure. This is the cloud broker model: service intermediation, service aggregation, service arbitrage. It's along with the basics of coming with the cloud carrier. This is the reference architecture model for NIST reference architecture. Next, we see the IaaS model. What is IaaS model? It is a cloud computing model providing virtualized on-demand computing resources, servers, storage, and networking over the internet on a pay-as-you-go basis. It eliminates the need for maintaining physical data centers, allowing business to rent infrastructure from providers like Amazon Web Services, Microsoft Azure. This is the IaaS model. First we see the data center, and next network and data storage for the input, and IaaS is the cloud, connecting with the cloud, reference to the servers, and virtualization connecting with the reference output model. Next one is software as a service. Software as a service is a cloud-based software delivery model where users subscribe to applications over the internet rather than purchasing them. Microsoft Azure and Oracle note that providers manage infrastructure security and updates, providing lower upfront cost and automatic updates. It is popular for its scalability, allowing businesses to use, manage, and pay for software on demand. This is the software as a model. This is a business model. How we are business doing as a software as a model? First one is premium and fast pricing, peer user pricing, tiered pricing. Tiered pricing means we have to set the tier 1, tier 2, tier 3 company, and this is the peer user, peak to peak and non-peak hours, non-peakable consumers, premium users. Next one is hybrid pricing, user-based pricing, flat pricing. These are the basic models for how we are consuming our product. Hybrid pricing means this is the consumer online products like virtual mode, Zoom, and Outlook meetings we are using as hybrid pricing. Usage-based pricing like AWS applications, some other on-demand pricing applications we are using as a user-based pricing. Flat pricing, we are paying the amount on demand basis, we are using as a flat pricing model. Next one is PaaS model, platform as a service. Platform as a service is a cloud computing model where a provider delivers a complete managed environment for developers to build, run, and manage applications without the complexity of maintaining the underlying infrastructure. This is the PaaS platform as a service over the data centers, net centers, and client and servers and emails, mobile applications. All are the parameters used as a platform as a service. Architecture cloud storage reference model. The cloud storage architecture is a distributed system typically comprising a user-facing front-end API, web browser applications are the examples, a middleware management layer, and a scalable, highly redundant backend infrastructure. It relies on virtualization to pool physical storage resources, providing on-demand, reliable data access across multiple geographically dispersed locations. This is the architecture cloud reference model how we are using as a. One is for client, another is for master. Client is the end user system, master is a name node or job tracker. We are called as a slave 1 and slave 2, data node for slave 1, task tracker for and map reduce for this slave 1 model. Slave 2 model same as data node, track task tracker and map route for scalable and flexible for the all the applications. Next one is cloud deployment model. A cloud deployment model fundamentally determines where the infrastructure for your deployment exists on and who owns and controls the infrastructure. It also figures out the nature and intention of the cloud. Type of deployment models. First one is public cloud, private cloud, hybrid cloud, community cloud, and a multi-cloud. So next one is how the deployment cloud this model. Public cloud makes it possible for anybody to access system and services. The public cloud may be less secure as it is open to everyone. The public cloud is one in which cloud infrastructure services are provided over the internet to the general people or major industry groups. The infrastructure in this cloud model is owned by the entity that delivers the cloud services, not by the consumer. This is the cloud reference model for deployment for public cloud. Enterprise, one is the private concern, cloud service provided for the another concern for connecting medium, enterprise queue. P is the input, Q is the output. So user is the they are connecting with the internet over the cloud service provider. Next one is the private cloud. The private cloud deployment model is the exact opposite of the public cloud deployment model. It is a one-to-one environment for a single user, it's for a customer. There is no need to share your hardware with anyone else. The distinction between private and public clouds is in how you handle all of your hardware. It is also called the internal cloud and it refers to the ability to access systems and services within a given border or organization. So we have to do again same model enterprise P. Cloud service provider for on premise private cloud, externally hosted for private cloud. Enterprise P cloud service provider. This is for dedicated for enterprise P. First one is cloud service for only one system. This is for dedicated to the enterprise of the system. So next virtualization cloud computing, how it is possible. Virtualization is the fundamental technology that powers cloud computing. It allows you to create multiple simultaneous environments from a single physical hardware system. Type 1 virtual model, bare metal model. This is the create runs isolated virtual machine. First one is physical compute hardware. Second one is hypervisor. Third one is guest 1, guest 2, guest 3. This is a separate application and a separate application for 2, separate application for 3. Example for Linux and Ubuntu and iOS. This is the application for using this virtual machine. Second one is type 2 virtualization like hosted model. Same run as application. Full OS host delivers software isolated. This CPU, RAM and storage for basic fundamental. This is the physical computer hardware. Second one is host operating system like OS, Windows, Mac OS or Linux. Third one is hosted hypervisor. Only depending upon OS, we have to separate putting as a Linux open source software like Linux or Ubuntu as an application for using as a guest OS for guest 1, guest 2. Virtual machines for cloud instances. After installing virtualization software, you can create one or more virtual machines on your computer. Virtual machines behave like regular applications on your system. The real physical consumer computer is called the host, while the virtual machines are called guest. A single host can run multiple guest virtual machines. Each guest can have its own operating system, which may be same or different from the host OS. Every virtual machine functions like stand-alone computer with its own statics, programs, and configuration. Virtual machines access system resources such CPU, RAM, storage, but they work as if they are using their own hardware. Thank you.